Gurubhyo Namaha. Welcome back to our channel.
Hello viewers and dear students. Myself Varlakshmi BS, DFA, BE and Tech. Today let's solve the most expected questions from Parabola. They'll show that the equation of common tangent to the circle x square plus y square is equal to 2a square and parabola y square is equal to 8ax for all a greater than 0 is y is equal to plus or minus x plus 2a. This is the problem they gave. Okay. Solution is, first you write y square is equal to 8ax, which I can write in standard form 4 into 2 into x. Right? This is same as this, right? So I will call this as equation 1. And x square plus y square is equal to 2a square. I call this as equation 2. These are given, right? They gave this in question. Now you write the standard equation of parabola, that is y square is equal to 4ax. I call this equation 3 and x square plus y square is equal to r square. I call this equation 4. Right? By comparing equation 3 with equation 1, we get a is equal to here 2a. Okay? And comparing equation 4 with equation 2, it implies r square is equal to 2a square. In other words, r is equal to square root of 2a square. Therefore, r we got a square root of 2. Right? Also, we know the equation of tangent. Equation of tangent for parabola y is equal to mx plus c, but c is equal to a by m, right? But here a is 2a, so it is 2a by m. Okay. Now substituting these values here, we get y is equal to mx plus 2a by m, or m square x plus 2a by m. So ym is equal to m square x plus 2a, or m square x minus ym plus 2a is equal to 0. I call this equation 5. Okay. Now from the given data, they are saying this equation touches equation 5, that is x square plus y square is equal to 2a square. Okay. Now substituting the values for this equation, we have r is equal to a square root of 2, and this perpendicular distance of this equation is, it is simply mod of xm square minus ym plus 2a by square root of coefficient of x is m square, right? Whole square plus coefficient of y is minus m. Okay. So which is equal to x minus ym plus 2a by square root of m power 4 plus m square. Now substituting these values in this equation, we get 2 is equal to 2a by m power 4 plus m 2. A square root of 2 m power 4 plus m square is equal to 2a. Squaring on both sides, okay, squaring on both sides, we get a square into 2 into m power 4 plus m square is equal to 2 to the 4 a square, right? This anyway get cancels. So what you will get is m power 4 plus m square is equal to 4 by 2, which is equal to 4 plus m square minus 2 is equal to 0. If you find the factors, we will get here it is m power 4, so it is 2m square 1m square, but anyway it is plus sign here, so it is plus and this is minus, right? So m power 4 plus 2m square minus m square minus 2 is equal to 0, or m square if I take common plus 2, and if I take minus 1 common, it is m square plus 2 is equal to 0, or m square minus 1 m square plus 2 is equal to 0. Therefore, the valid value is m square minus 1 is equal m square is equal to 1, which implies m is equal to plus or minus 1. You substitute the value of m in equation 5. Okay. If you substitute these values here, you will get, if m is equal to 1, you will get it is x minus y plus 2a is equal to 0, or y is equal to x plus 2a, right? And second case, if m is equal to minus 1, you will get it is, anyway it is minus 1 square x minus of y plus 2a is equal to 0, or it is x plus y plus 2a is equal to 0, or y is equal to minus x minus 2a, which is equal to minus of x plus 2a. Therefore, the required common tangent equation is plus or minus x plus 2. Okay, from this. Understood? Now let's see one more problem. Problem what they'll ask is, they'll show that the area of triangle formed by tangents at x1 comma y1, x2 y2, x3 y3 to parabola y square is equal to 4ax is 1 by 16a mod of y1 minus y2 into y2 minus y3 into y3 minus y1 square units. Right? This is the question. Now, how to prove this? First, we know parametric coordinates, right? Parametric coordinates of parabola is 80 square, 280, right? Also, equation of tangent of parabola at x comma y is ty is equal to x plus a t square. Okay. Now they are saying the area of triangle formed at tangents at these points. Let D is x1 comma y1 and EB x2 comma y2, FB x3 comma y3. Let these be points on parabola. Right? Then the corresponding parametric equation of point DEF will be a t1 square comma 2a t1, a t2 square comma 2a t2, a square comma 2a. Okay. Similarly, the equation of tangents of corresponding DEF will be, so similarly for points E, the equation of tangent is T2y is equal to x plus a T2 square, and for F it is T3y is equal to x plus a T3 square. I call this equation 1, 2 and equation 3. Okay. Now equation 1 minus 2 gives T1 y minus T2 y is equal to x plus at1 square minus of x plus at2 square, right? Which implies here y is common, so T1 minus T2 is equal to, anyway this get cancels, a T1 square minus a T2 square, a into T1 square minus T2 square. Okay. Now I can write this as T1 minus T2 is equal to a T1 plus T2 into T1 minus T2, because it is a square minus b square formula, right? It is a plus b into a minus b formula. I expanded by using this formula. Okay. Now anyway this get cancels. Okay. Therefore y is equal to a of T1 plus T2. Now you put this value in equation 1. Okay. This in equation 1 gives T1 a T1 plus a T2 is equal to x plus a T1 square, right? So a T1 square plus a T1 T2 is equal to x plus a T1 square. Anyway this get cancels, so we get x is section of D and E. Points D and E is x value is a T1 T2 and y value is, much we got here, a of t1 plus t2. Right? This is intersectional points D and E. Okay. Similarly, if you do for equation 2 minus 3, you will get the intersection point of intersection at E and F. You will get is A T2 T3 comma A of T2 plus T3. Similarly, if you do for other points of intersection, you will get it is A T3 T1 comma A of T1 plus T3. Okay. Now we need to find the area of triangle formed by the tangents at these points. Right? For that, the formula is, if I consider that triangle as PQR, then it is absolute value of 1 by 2 into the determinant of x terms is A T1 T2 A T2 T3 A T3 T1 A of T1 plus T2 A of T2 plus T3 A of T3 plus T1 1. This is the formula. If I solve this determinant, absolute value I just represent, right? So by solving this, what I get is area of, this is the area of triangle. Area of triangle PQR is equal to absolute value of 1 by 2. If I take A as common to all first column and second column, you will get A into A, and the value of determinant will be T1 T2 T1 plus T2 1 and T2 T3 T2 plus T3 T3 T1 T3 plus T1 1, right? So which is equal to absolute value of A square by 2. Here I will take R dash is R1 minus R3. Okay, that implies T1 as common, T2 minus T3, and here T1 plus T2 minus T3 minus T1. Here anyway 1 minus 1 will be 0, right? This get cancelled. Okay. Similarly, R2 dash, I will take R2 minus R3. Okay. Then what you will get in here, T3 is common. So T2 minus T1 and T2 plus T3 minus T3 minus T1. Here this will be 0. So T3 get cancels. This will be same. Right? Okay. So here, if I take T2 minus T3 as common, A square by 2, and this I will take T2 minus T3 common, and here T2 minus T1 as common. Then the value of determinant will be T1 1 0, T3 1 0, and T3 T1 T3 plus T1. Right? Now by property of determinant, the value of this will be, okay, which is equal to a square by 2 t2 minus t3 t2 minus t1 into t1 minus t3. And this is absolute value. Okay. Right. So t3 2a t2 minus t1 2a t1 minus t3, right, by 2 into, see here only a square is there, but I have added one more a, right? So if I multiply by a, I need to divide it by also a. Understood? And also 2 2s are 4, 4 2s are 8. I have multiplied the numerator by 8. So I need to divide it by 8. Okay? Understood? Now if I expand this, if you see this 2a t2, right, this is y2, then 2a t3, this is y3. So if I substitute the values, triangle PQR is 1 by 16a into y1 minus y2 minus y3 minus y1.
Don't forget to write units.
Okay. Hope this video is helpful for you.
Support
If so,
us.
kindly give a like, share with your friend circle, and don't forget to subscribe our channel. Thank you.